Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Apologies if I sound a little tired or something. DST got me pretty good this weekend, so we're in the no sleep gang today. So
Yeah, the
we'll
perks
we'll see
of
how it
not
goes.
having DST. Everything's just an
Yeah,
hour
I
earlier
envy you a
for me
lot.
now.
I envy the lack of DST though. I hate it.
Yeah, I mean,
It's all good. Where I live, it's gonna be going as soon as New York gets rid of it. So never. So it's all
yeah,
good.
I'm sure that'll be happening anytime now.
Yeah. But yeah, in this episode we have an exploit chain in Pascom's cloud phone system, named AutoWarp, which affects the Azure automation service, and a container escape in GKE Autopilot. So we'll start off with Pascom, which
Well,
is the
before
cloud
we
phone system.
start off with that, I will also just shout out here that this is officially, well, I guess a couple days ago was the channel's third birthday or anniversary or whatever. Um, so figured I'd shout that out.
Yeah, it's pretty well. We've been doing this for 3 years. It's funny because you look back at some of our first episodes of the podcast, and they were like 2 to 2.5 hour long, like stretches where we were talking about all sorts of different topics, like
Well, I think
going
our
deep into white papers and stuff. It's the show has changed over time quite a bit.
Yeah, our first episode, I think we spent like what, an hour and a half just playing with Ghidra.
Yep, Ghidra was our first episode. Was right after Ghidra released, basically. So we that was kind of our catalyst, I guess, to start doing the podcast. So yeah, but yeah, good call out. 3 years, crazy. Doesn't really feel like that long, but it has been. All right, so yeah, we'll get into Pascom, which is the cloud phone system, primarily aimed for businesses, but I think they also offer it to individuals as well. Um, the way it works, they go into a bit of the background here on the infrastructure and the setup. There's basically like this central Linux-based operating system, which then hosts containers of its own for different services. They mentioned there's 4 different containers for things like running databases and web UI services and whatnot. The web UI is Java based with Tomcat and uses Nginx reverse proxying. Seems like kind of an interesting setup going on there with the use of containerization. 3 bugs were found after researchers at Kerbit downloaded the trial and tested it in VirtualBox. And this is basically a path traversal, an SSRF, and a command injection that can be chained together for RCE. Now, that RCE will be in the context of within the container and not the host OS, but the impact is still significant because you're still able to access service data inside the container. So the first bug was the path traversal bug in an Nginx rule that allowed access to non-exposed endpoints due to a desync bug between Nginx and Tomcat. Those who are watching can kind of look at the rule um, that's written here on Nginx. Basically, they perform a rewrite on the service's plugin script path where it'll take whatever comes after it and pass it to a service running on port 9090 to perform a request. And that pathing info is stripped out. The problem is you can use a fairly known trick of doing like dot dot and then semicolon slash. And what happens is Nginx will see that as a directory with the semicolon being a name directory, whereas Tomcat will just normalize that and see it as a dot dot slash. So using that, you can smuggle a path traversal in and access not exposed endpoints.
Yeah, and
Kind of a straightforward bug, but
I'll
still a
say
cool
that
one whenever you see those
uh,
desyncs.
I kind of disagree on saying this is a problem with the Nginx rule. I feel like this is more just uh, I don't know. I tend to look at this as Tomcat being a little bit weird when it comes to the path deciding to strip that out. I get it; it's a fair choice, but I kind of put the blame on Tomcat letting that happen. Because I mean, it is just a difference in how they normalize things and how they look at it. Because I mean, it's not like Nginx won't do some normalization. Also, they just differ on what exactly gets normalized. You could put the blame anywhere. I don't think the rule itself is implicitly all that bad to just say, capture whatever comes after this path, because in theory, Nginx is normalizing it so like a dot dot slash isn't getting included in there. It'll find the right service. So you don't want to mess with all of the potential paths and queries that could be provided You just want to say, as long as it starts with service plugin script, send it along to the Tomcat service. And then Tomcat acts a little bit weird, supports this trick basically, and thus I still kind of put the blame more towards Tomcat, personally.
Yeah, I kind of agree, but it's one of those problems that's so easy to pop up when you don't have like standardization of handling something as simple as like file system stuff. It's one of those areas that it's kind of a wild west, and that's how you get these kind of issues that crop up. So yeah, because there's that desync, you can smuggle in a path reversal and access those non-exposed endpoints. The second bug was a SSRF through the favicon servlet. Another fairly straightforward issue: the servlet would take a host parameter from the GET request and use it to construct a request URL, and it does no validation on that host parameter. And what's more, these requests essentially bypass any forms of authentication since they come from localhost, which is kind of a common pitfall we talked about as recently as last week, I believe. Assuming that requests from localhost are secure and just
So
not authenticating them. So
so I'm not sure if that's relevant on this one. They do talk about the local host aspect when they come to actually hitting the Pascom API, which is what they use this server-side request forgery to hit, rather than the get favicon actually requiring that you are actually having any authentication in the first place. It sounds like basically this get favicon, they could only hit that, like it wasn't exposed whatsoever. Um, this one they could only reach because they were doing the Tomcat trick to get onto another service, basically, besides the one they're actually supposed to get routed to. So they do that to hit get favicon, and then from there, they're going to try and hit the REST API for the sensitive information. And that's one where if you're coming at it from the internet through Nginx or whatever, it's going to check your authentication. But if you're local host, like using this SSRF, then it's not going to do the authentication. I think that kind of comes into play on the next step when they're trying to hit this sysinfo active config endpoint.
yeah, so by chaining those two bugs together, you kind of open up the exploit vector for the third bug that they mention, which is in the tasks scheduling service, ext.pl, which runs as root. Basically, whenever a task request is issued, it gets put into a database, and the service will read from the database and execute that task in kind of a first in, first out fashion. Because of the SSRF, you can get a request sent that will schedule a task that you can specify arbitrary arguments for. So in the POC here, they did an RMRF on a target directory, for example.
Um,
The
you've
last bug
missed a
seems to
step. I'm
be.
sorry. I'm jumping in here really quickly
Did
because
I?
I
I might
believe
have.
you missed. Yeah. Because what they did was they used so you come in using that Tomcat path traversal, and that gets you access to get favicon. And that's where the SSRF is. They use the SSRF to hit this sysinfo active config file, and that file contains credentials for a privileged REST API user. And then they use that privileged REST API user to make the scheduled task, which then has the command injection. They did need to
Yeah.
leak the credentials first to get that password for a built-in REST user that can access basically everything.
Yeah, sorry, you're totally right. I don't know how I skipped over that because I have that in notes, but I just yeah. Thanks for bringing that up then. So yeah, once you have those credentials, then you're able to do the attack I was mentioning with scheduling a task to get code execution. Um, the last bug, it seems to be more of just like a supported functionality that's supposed to be gated off and would be in normal circumstances, but because of the exploit chain of the bugs that came before it, the assumptions of security that were made were basically broken.
I
So
feel like I'm needing to jump in a lot on this one, but there is a
okay, go ahead.
proper command injection in that. So in that task log, what the task is meant to do. And this is just task ID like 050380. It's a random number, but what it does is it takes up to 4 parameters. 2 of them are necessary. Tar file, which is literally give it the tar file. Target directory, it's going to extract the tar file into. And then an optional next parameter is delete output directory. It's basically like clean up all the files before it extracts it. So if there's anything already in that folder, delete everything. That's where the vulnerability gets introduced. you have the when if delete output directory is actually enabled, so you set that as that third parameter, set that to true, then it's already kind of figured out what the target directory is, checks if it is a directory, creates it if it's not. Well, creator is its own option. And then it calls this execute rmrf, gets the real path to the target directory /star. So just delete all the files under that directory. The problem there is that it takes this real path and it's not in quotes or anything. It's not escaping it. So if you have a directory name that can be created, it does have to be a valid directory name, so there's a little bit of a restriction there. But you could have like a semicolon in a directory name that is legitimate. You would just need to kind of quote that and escape it, or otherwise escape it. If you were actually trying to delete it. So in this case, when it does that real path, it comes up with a real path to a real directory. But that can also just escape the command being executed, semicolon, and have another command in there. Which I believe they show what they did here. Yeah, so they end up using just shell expansion, so $, bracket, and then an actual command to execute as kind of being popped in there and giving the shell command. It does limit a little bit what you can do because of the fact that it does have to be a directory. But there is a bit of an actual injection there. You're not supposed to have code execution.
Okay, fair enough. So yeah, basically what's happening there is you can execute a task ID or a script. I kind of conflated that part of the article with what they talked about a bit later on with like after they've exploited that issue and gotten a remote shell. So I think that's kind of what happened there. And in my mind, I got them mixed up. So yeah, fair enough. Good call out on the command injection. But yeah, I mean, overall, I mean, these are kind of bugs where individually they might not be super impactful, but when you chain them all together, uh, it gets you. You know, the sum is greater than the whole, or whatever. However you do that quote. I'm too tired. I'm sorry, but yeah, chaining them all together, the impact is pretty high there. All right, so we'll get into our next post here, which is a post on 2XSS and a cache poison chain that was reported to the Glassdoor HackerOne. Z, I know you found this one interesting, so I'll let you take this one away.
Yeah, this one was interesting in part just because the XSS, there's kind of two XSS injection points, but only one actual XSS attack. And they're attacks that normally, one, a lot of people don't really look for them, because they're going to be very hard to actually exploit in the wild, but they did also manage to exploit. So looking at it, the first XSS, or the first injection point at least, that they found was in the cookie, specifically I believe it was GDID gets mentioned in the HackerOne report. It's not mentioned here. They just say like cookie name, but they found an injection point in a cookie, and that was basically like you can provide. It was being reflected into a script already, so you just had to kind of like end the script. It looks like is what they were trying to do. I'll be honest, I'm not entirely sure if there were other routes they could have gone for injection that could have avoided triggering the WAF, but the deal here was that the web application firewall was basically blocking their actual attempts because they couldn't have anything like angle bracket, word angle bracket that would end up tripping it up, or angle bracket slash. Basically, you can't have the two angle brackets in there. They end up calling out specifically that their %20 or space couldn't be used. That's kind of a common trick, because the browsers will still support tags with spaces in them, but a WAF may not be configured. So basically, they couldn't end their injection properly, and thus they weren't able to get anything to execute yet. Which is where they also found nearby was their IP was being reflected. And this is kind of the part of the attack I like, is they were able to modify or provide a exported 4 header and get that also reflected in the page, getting XSS through that exported 4 header. Well, combination of the two, by getting to abuse exported 4. And we were just talking about last week how you could have all these issues with trying to get the real client IP, and if it's coming out the header, it might not even be an actual IP. As is this case, they were able to provide part of the script through there. Um, Ultimately, the other problem here is cookies and headers. You might be able to find an excess there. You're going to have a hard time actually trying to exploit that because it's not like you can provide somebody a link or save it or something so they can actually be sent to a victim. Which is where the third issue, straightforward cache poisoning attack, where all they need to do is have an extension on the file being like .js or .css. Seems like the way routing was set up in this case in the HackerOne report, they use the example of like index.php/.js. As we've talked about before, how PHP will, even though it kind of looks like it should be a directory, PHP will see that there is the file, or often the setups will see that there is a file there that is index.php and treat the rest of it as just the query string for that PHP file. So that's what's going on here, I believe. Um, Basically, routing's messed up, so you can end up having the .js or .css there, giving you a cache poisoning because that request gets cached. They just use something kind of random in the URL, so they can give that to whoever they want, and you've got stored XSS using headers, which I think is always kind of a neat vector to see. It is one of the only ways that really comes to mind, unless the application's actually saving something out of headers, and then you've got a more direct stored XSS. But one of the few ways that you can actually exploit a header-based cross-site scripting attack.
Yeah, and like you said, it was neat how this exploit tied back to that topic we were talking about last week about how the the client or the attacker can have complete control over the exported for header, and it doesn't have to be an IP. So yeah, the timing on that was pretty cool. But yeah, I mean, not really any complex bugs in there, but yeah, just some cool tricks. So
Yeah.
yeah, I like that post. All right, so we'll get into the named vuln for the episode, which is AutoWarp, and this is a bug in the Azure automation service, which we've talked about a little bit on a previous episode, maybe like a year ago or so. I want to say, I don't know, it might have been more recent than that even, but it's basically like a sandbox environment where you can schedule jobs and configure inputs and outputs. It allows you to run scripts like Python or PowerShell or whatever on Azure. It can be very useful for certain developer use cases. The researchers at Orca started out looking at the Azure automation service by checking out the file system, just doing some reconnaissance on what they had access to and whatever. And then when they found some log files, they noticed something kind of interesting. There were references to a web service that was running on port 40,008 on localhost. And it made mention of being the asset retrieval web service, which they thought was quite interesting. They actually did some reversing, threw it into IDA and tried to find which different routes and stuff were supported. They ended up finding some OAuth 2 token routes that went through this MSI controller or managed service identity, and it turned out that on this endpoint, if you just sent a metadata request by specifying the metadata header, you would get a JWT back, which was tied to your tenant ID and whatnot. Um, and there was like no like authentication or authorization on that endpoint. And when they started scanning for other ports, they found they got different tokens for different tenants. So that's kind of where the attack comes into play. It seems they were using the ports as a sort of identifier into this asset service portal, and yeah, they just had this endpoint exposed with no authorization. I think they made mention of this being a little bit of a red flag too, towards the top of their post. Just
Yeah,
mentioning that whenever
that's
you see these like high port numbers that seem to be random, that there's probably some kind of complex setup going on there that the developers are trying to account for. So
not
it's a good
necessarily a
area to look for
complex
issues.
setup, but just kind of the idea of, and they mentioned this, just having like all the other ports have been taken, like it's not a service that they can just run on a, low privileged port or something, which
Yeah.
is kind of a red flag because, I mean, in this case, they're running one of these services basically for every tenant on the box. Which ideally, you'd probably want to run just a single box that can then authenticate maybe the process, use authentication at that level. There's a lot of ways you can actually go about doing that authentication, but having a single service that does this rather than spinning it up for every single one. yeah, it is like having random services being run like that is questionable. I believe they didn't really well, they kind of scanned for it. What they noticed was they just did like +1 on their port and then saw they were able to get data back and then did the metadata and were able to get other tenants JWT tokens, which yeah, that is definitely an issue. It's frankly a really stupid issue to have and to have it deployed this way. Like it really is that straightforward. They were like you can get the tokens of any other tenant on the same box. I guess I'm
Yeah,
saying tenant. That's maybe not the best terminology to use, just because nobody really persists. These are meant for a bit more shorter term runs.
yeah, it took me a bit by surprise of how simple and straightforward this issue was because usually when we're talking about cloud and Azure, we're talking about a bug that's caused by multiple layers of just different interactions or edge cases that weren't really accounted for. But in this case, like, yeah, it just seems like a lazy design decision, I guess, or like a lazy implementation. Um, the fix for this issue that Microsoft did, which they detailed towards the end of the post, was they require the X identity header when requesting identities. So if you like that value has to be set to a secret that's set in the environment variables. So they kind of have a bit of authorization there on that endpoint now. But yeah, it's crazy that that wasn't there in the first place, especially on something like Azure Automation. So yeah, very interesting.
Yeah, I mean, it's less of a concern if, say, and I was kind of thinking about this on the testing aspect. It definitely depends on how this wouldn't have been discovered earlier. And if they're doing like, you give a uh security professional like just access to test it, some information about how it's running. I could see this maybe being overlooked if they're just so like, yeah, it spins up this process for you there. And if they're testing with their own account, not necessarily running multiple things at once. Like there are ways, ideally, you should be, running with multiple accounts and everything. I've had some clients that don't like to provide multiple test accounts, so I could see some like that coming up as to how this wasn't really discovered much or quicker. It is one of those things that can be overlooked because with just a single client, so if these were running, if they spun up like separate instances for everybody, wouldn't actually be an issue because nobody else has access to the box. It is specifically because they also run multiple users on the same box or within the same environment.
Yeah. And with that, we can get into our last cloud focused topic, which is from Palo Alto Networks and focuses on Google Kubernetes Engine or GKE. Specifically, its autopilot mode, which I think is a bit newer. Uh, it's kind of what it sounds like. It does some automatic management of Kubernetes clusters and such. It tries to take a bit of the load off of developers trying to use Kubernetes. And yeah, I'll let Z jump into this topic here as well.
Yeah, this one, really good post, a lot of background, and kind of an interesting set of bugs leading to it. So with Kubernetes, you've got your cluster, and you ultimately end up at the lowest level. You've got a VM that will have a container that's actually running whatever workload it's supposed to be running. So then you escape the container into the VM, and you still need to escape out from there, to take over the entire cluster. And they go into a bit more detail about what the actual cluster might look like. And no, it's like they go into all of that. There's a good deal of background, not a ton, but there is some at least. So going on with that, first escape, getting out of the container. All they were or they had this whitelist of certain workloads. Or yeah, they say here allow listed workloads to compromise nodes. Um, I mean, it's not quite masquerading as allowed list is what they actually say, but the idea is they did have an allowed list that would be allowed to compromise the host essentially. What they had was in this allow list, see if I can pull it up here. Yeah, so they listed the image, a command, and it would basically validate based off that. Is this the image of whatever the container is? Is this the command that it's set to use? And it would have the constraints that could basically be or it would have basically what it's allowed to do. So it's allowed to mount, specifically in this case, the one that matters is var run container D, which is your container D socket. So Datadog, and only Datadog in this case, is allowed to mount the container D socket. The problem here is you'll notice this command is just bash-c, and then -c is basically just execute whatever commands are provided afterwards. So even though they're making sure the right image is running, you can provide or you can spin up a Datadog container that has different arguments. And those arguments are going to go into C. So you can run any code you want in this image. So even though it's doing this validation, it's not sufficient. Ultimately, getting your own shell inject or run whatever shell commands you want into bash-c by providing it as the argument instead of the command. So if masquerades that, then it's allowed to mount the container D socket, which it can then use to spin up a new privileged container just by communicating directly over that socket with the VM's container system. Communicates directly with that, spins up a privileged container that has access to the entire host file system. And host in this case is still just the VM. And at that point, they can basically compromise, or well, what they do is they install a systemd service that will then spawn a reverse shell, giving them code execution on that VM. And that gives them access to all of the other tenants that are also running in that same VM, their service account tokens or instance metadata, the kubelets, credentials, basically all of that. So from that point, they're on the VM, they've got code execution, they have access to all of the tenants on that. So they started looking, well, what are some of the default tenants? What are some of the privileged pods that might exist? That's where they find they've got the cube system namespace, and 2 pods are installed by default within that namespace. Doesn't really matter the specifics about what they do, and they don't even go into that. All that matters is that cube system namespace, since they're inside of that namespace, they can basically do whatever the heck they want. There's essentially no restrictions on those containers. So you would have to use the first thing and escape the VM into one of the VMs escape the container into the VM. You would have to escape into a VM that is running one of those pods. So that is kind of the first requirement here. You escape, you get onto that privileged pod, and then because you're able to access all the other tenants at that point, you're able to get the service token for one of those privileged pods. From that service token, go ahead and update the deployment service account and add your own malicious container into that deployment, at which point your malicious container can go and read the Kubernetes service account token, which is more privileged and effectively compromise the entire cluster at that point. They do also talk about one cool backdoor option. Through Autopilot, you have the administrators using Autopilot have no insight into Kubernetes mutating admission webhooks, which is essentially whenever an object is created, like a Kubernetes object is created or updated in that cluster, that's things like the pods or the secrets, importantly, it's going to send a message off to this webhook and let the webhook modify any of them if they want to. So all of the secrets all of the secrets created or updated, they're all going to be known by this webhook. And the administrators, they don't have any insight into these. So you can, because you have this complete access effectively, you can install one of these webhooks, and nobody except people actually working at Google, and they shouldn't be analyzing every single cloud to find that. Basically none of the administrators who are actually running this workflow are going to be able to see the webhook, creating a very stealthy backdoor. Honestly, it's a good post. I tried to run through a lot of the details, but they go into a good bit more, and also into a little bit more of their process for having kind of come across it a little bit. They talk a little bit about their own tooling also. So there is more information to go with there, but that's the gist of it: escape into the VM, and then the cluster takeover.
Yeah, this attack chain basically allows an attacker to privilege escalate higher than the admins that would be administering it. So that was kind of a cool aspect to it for sure. Google did take a fair number of steps here to mitigate and fix these issues when they were reported. For one thing, they hardened the verification of that allow listed workloads. They don't really go into details on what specifically that entails, but um, I'm guessing they've looked into it and found that it was sufficient for protecting against any variants of this. They also further restricted the kube system pods, which were used for escalation. They added a new policy which prevents pods from assigning a new service account to an existing pod, which kind of makes sense and blocks the attack strategy that they went with. Um, they also gave cluster admins some increased permission to be able to list, view, and create those mutating emission webhooks, which kind of impacts on that backdoor that Z was talking about. At least now they would be able to see if one was created, and be able to manage that. And there were some other steps taken there as well, which you can check out a little bit in the post if you're interested. Like Z said, there's a lot of background that they go into and a lot of like thought process that we can't really cover here because it wouldn't really do it justice. But there's a lot of interesting information in here for sure. Um, yeah, I found they went into a good bit of background on the built-in policy, which we didn't really touch on too much because it was kind of like the issues they found got around it, which was kind of the whole point. Because the service counts are exempt from the built-in policy, so that's why they attacked them in the first place. But just some of the information on the built-in policy and what they had to do to get around that was interesting to me too, beyond just the vulnerabilities themselves. So yeah, really solid post all around.
Yeah, and thank you, I Hate Chemistry, for the 3 months of Prime sub.
Great name, by the way. All right, but yeah. Unless you have anything else you want to add on that topic, Z, or any others, I guess we'll go ahead and wrap up the show.
No shout outs this week.
All right, cool. So that's everything we have for the bounty episode for this week. Thank you to everyone who tuned in. The VOD will be up on YouTube and Spotify as well as other platforms tomorrow. Check out our Discord and follow us on Twitter for when we go live and for discussion. Links for those are on our site or in the chat. Remember to tune in tomorrow at 7 p.m. Eastern, 4 p.m. Pacific when we'll be live with the binary episode, and we'll see you then.